The code compiles.
Yes.
The code compiles.
Yes.
So this has been one of the hardest problems in AI code generation. One we thought was going to take a while to solve across the industry, and Blitzy is the first to do it. So what's the breakthrough?
Let's talk about the problem, right? When you're working with a Copilot, your favorite chatbot, IDE tool, CLI, whatever it is, you're writing the prompt, give me code to do this.
Yeah.
It's writing the code. You try to run the code in the same tool, chances are there's a 50% chance it works. I'm basing that on the acceptance rates, right? But there's clearly a 50% chance that it does not. And then what that means is you're going to do back and forth. Like, okay, I got this error. You're probably making a syntax mistake or you're not getting things right. And then you have that back and forth, right? So to get something to actually compile and work, you've done 3 prompts. Maybe you've changed the model somewhere midway because you got frustrated and you thought it doesn't have enough context. And then even after it compiles, you have to then run the tests. And there's the added frustration of, okay, this worked, but it broke other things downstream. Now I got to fix all of that.
Yeah.
So that is a frustrating problem that we've inherently solved using Blitzy. And the biggest breakthrough that we could get into detail over the course of the conversation is Blitzy's approach to writing code, specifically spec-driven development and test-driven development. This is a bet. This is an architectural bet. We made a lot of bets, as you know, we on this journey. But one of the biggest bet we made is an aspirational goal that enterprises have, where you want to engage the developers and ground them in a spec. You want to do the spec before you write the code, and not the other way around. Because what happens the other way around is that the code does something else, and you've written the code, but now you have this overhead that only the developers who wrote the code actually understand it, and you have documentation debt.
Yep.
Right. So that's why you need spec-driven development, and test-driven development is similar in the sense that you've written all the code, but you don't have unit tests, so you don't know if it actually works until users do the QA for you. So you write unit tests, but it's always like this: you're writing more code and you're writing more tests, and the two never seem to converge, because you always never have 100% coverage unless you're elite, of course. So we've solved that problem for you as well, where we write the tests before or with the code. And that ensures 2 factors, 2 controlling levers on the code. And we're going all the way to run the code eventually.
So right now, if somebody ingests a code base, could be 1 million lines, could be 100 million lines onto the platform, and expresses their intent, whether that's a refactor, whether that's a feature addition, whether that's a CVE, addressing the CVE in the code base, they run that through Blitzy. Their output will not just be code that addresses the functional requirements, but it'll have been pre-compiled and pre-tested.
Exactly. So all of that process that I talked about, that difficult, frustrating experience of figuring out which model to use for the job, of working through slightly different outputs, of making sure that this works and the other stuff works as well, has been solved for you by Blitzy, by leveraging multiple models. In many cases, we've created the equivalent of fusing models together to expand the context window. And we've made sure that the prompts that were written for the agent that worked on your file by another agent that understood the context of your code base and your requirements and your spec, we make sure that all of that is just perfect, right? What pre-compiling implies is that we've tried to compile and fix any bugs before you got the code back. And similarly, pre-testing is that we've written tests and validated that our tests pass. We've discarded those tests because those are our tests. So unless you've asked Blitzy to write tests, we're not going to write it. But if you did ask Blitzy to write tests, we wrote those tests and we ran those tests alongside your tests, and we made sure the entire unit test suite passes. So you have code that you can be sure is good, right? Yeah. It compiles and runs. And as I said, we're going to get into even starting your services, running your UIs, and making sure everything is pixel perfect.
So the enterprise users that were using Blitzy or have been using Blitzy for quite some time, even before this, have had incredible velocity gains because we're able to increase the quality of code a number of ways. In some cases, it would compile. In some cases, there would still be compile time errors, right? And it was worth it for the developers to come in, fix those compile time errors, move to the runtime errors, and get it into production, because the starting point was still so much further down the line.
Right.
And we would do all these estimation works with how much faster Blitzy was and how much work we were doing.
Right.
And we were netting out on a median case around 80% of the quantum of work we could address. And then the compile time issues were addressed by the developers. The runtime issues were addressed by the developers. And then we're still, doing typical QA.
Yeah.
And so that was the paradigm we've been in, call it the first half of 2025. So how much quantum of work are we doing now? And this is emergent because we're running a lot of tests. It's exceeding all of our expectations. In certain cases, we're wiping out weeks and weeks of additional work for projects that took years. We're getting them done in months. But what is the quantum of work we're at right now?
Yeah, that's a fantastic question. So we have this internal project, a POC, that was supposed to take about 6 to 8 months of work. And with Blitzy, it was more than 5 times faster. It took about 4 weeks.
Yep.
Right. And the 4-week milestone was that developers got the code to compile and the unit test to run.
Yep.
With these new improvements that we've now made, the Spec-Driven development, and we always had Spec with the test-driven development.
Yeah.
We're now able to get the code to compile and unit test to run out of the box. There's a 20% change in the amount of time it took the agents to write the code, which means if it took 5 minutes earlier, it takes between 5 to 7 minutes per file.
Per file. Yeah.
And then when you get the code, earlier it took like 2 days to get the code, and it's probably going to take 2.5 days.
Yeah.
To get the code back.
Yeah.
But the acceleration is not from 6 months to 6 weeks. The acceleration is from 6 months to a couple of days. So when you factor that in, what we've been thinking about while achieving this is how do we reduce developer frustration? It is frustrating building from scratch because you have to solve all of the other challenges. It was slightly frustrating having to fix issues because you get the code back, and we sometimes got questions like, you wrote the code looks structurally good, what's stopping you from getting it there? But there's a lot of really hard problems that you have to solve to get everything to work consistently. Like, for example, we don't know what commands you use to compile the code. Like, we have to figure that out. Agents have to figure that out. So there's a number of challenges that we had to solve. But the bottom line is that the vision of Blitzy, we've repurposed. So we had like 5 developers working on this particular POCs and POCs like this. Now, we repurpose them to more challenging problems, right? And the vision of Blitzy is you can bring months-long project down to days. And that's exactly what we're working towards.
Yep. And so what's left, and then what's next?
Yep. So what's left is, we've got this far, and we've seen that it is not just possible because, we always had people second guessing, like, is that even doable with today's AI? But our thinking on that has always been that the world and the industry is indexed far too deep on what just models can do, but not focusing, deeply enough on what systems can do, right? Models are tools in the broader ecosystem. It's the design of applications and systems that has been an age-old software development philosophy that is always going to win, right? You're always going to have better models, but it's only the systems that are designed to take advantage of the models correctly and are built to evolve quickly and adapt as things changed, right, that are going to win. And that's exactly what you can see with Blitzy. And code compiling is just a starting point. And the unit test running is also just a starting point. So we see incredible opportunity in setting up multiple terminals, running the code, validating runtime issues, fixing them, taking screenshots of the code and fixing pixel level gaps, looking at the original Figma and delivering code that aligns with that. Because again, that is another frustrating experience. And the focus of Blitzy is to reduce and eliminate developer frustration. And that is what we're indexing towards.
Ultimately giving the enterprise just incredible velocity gains and allowing them to think about a true transformation in what they're able to provide from a product and service perspective to all their customers. So we're in this interesting spot where like we knew this was possible many months ago actually, because we were able to do it, and then there's a whole other problem of getting to full reliability on every single case, and that's an engineering implementation problem that we know can be solved, but we knew this moment was coming for a few months.
Yep.
And so we're at a similar point with a few additional incremental inventions that we solve for that allow us to work through some of these runtime issues. One of those is this concept you've pioneered that we've called ARC, which is agent-ready components, where we've solved it internally, we use it internally, and now we are thinking about how we create the harness to drive this across component libraries, across all of the enterprises. So what is ARC and why does it matter?
Yeah, so if you think about UI fundamentally, UI is a much harder problem than everything else. And the people underestimate UIs because to write a UI or to get an LLM to spit out code that builds a UI is pretty straightforward. But to do that consistently, so if you go to, for example, NVIDIA's website or even Blitzie's website and you look at a button is a button no matter which page it is on, right? And that is also true for colors, design systems, right? For more complex components, design language, and the way you do animations, the way you use fonts, the way you render things, your spacing, the consistency of your spacing, right? The use of colors in different circumstances. There are teams of some of the world's most creative experts dedicated to this vertical that are really hard to hire for, right? So we want to solve that problem, and we wanted to make it easier for enterprises to solve these problems consistently using AI. And what we've seen, Lovable does a fantastic job of creating UIs, but the industry is dependent on open source MCPs. And as we've seen, AI and MCPs is still too early to trust at a system level, where we had, we've had multiple incidents of things going wrong. And we care deeply about security being enterprise first as our vision. So we've always opted to play it slower, taking a page from Apple's book, but do it right. And that's exactly what we've done with ARC, or Agent-Ready Components. So Agent-Ready Components is a design system and a component library that was built by some of the world's best designers and UI developers. And essentially, it takes into account all of the items that I mentioned about design, right? So you have you have typography, you have all of the color schemes, you have different a set of components that the designers believe are adequate for most design use cases. When you want to build rich enterprise grade UIs that scale, that are responsive, right, and that are reliable. And this is based on using a collection of components from a number of open source libraries, including Daisy UI. And Daisy UI, being pure CSS, has an advantage where you can use it with any framework, right? We've still built other more complex components into the system, and we've indexed towards React just because React is the most popular front-end library. But in general, the concept of ARC is that when an LLM, you can connect Figma to Blitzy, and you can give us access to your screens. You can cite the screen that you want to build, along with your backend, of course. So this is not just a UI only feature. It retains the infinite code context that we've achieved, and it looks at the UI as one part of the rest of your system, right? So the Figma is additional context that it uses to build your UI. The difference is, should you have a set of components that you prefer using, we would definitely use that. But let's say you don't have those components, we can use ARC, which is Blitzie's components and Blitzie's design system, and it interpolates your Figma into our components. So for example, if your Figma has, if it detects that it has a pop-up and there are like 17 buttons, for whatever reason, it's a busy dashboard, and it has tables or whatnot, and maybe this was just a sketch. It doesn't have to be a Figma, but let's say you had a Figma. We can interpolate that into our components. Our Figma is public, and you can look at what it's going to look like. And then it uses our components to build the UI. So the difference is, first of all, you're going to have much less code, but it's not just about the code volume, it's about reliable code, right? The LLM is not writing functionality to implement a date picker from scratch, right? Because that's a hard problem.
Yeah.
The LLM can write a simple date picker, but when you have edge cases and when you have different scenarios, like leap years or whatnot, it could run into issues, right? Like you get the point.
Yeah.
There are rendering issues, there are scaling issues when it's responsive, there are theming issues and all of that. So rather than solve that problem for every single component and UI, you use components that were written by, as I said, some of the world's best developers, that were designed by the best humans, right? And they've already taken into account all of these challenges at scale. So UI has the benefit of leveraging these atomic components. And when you focus the LLM's effort on orchestrating components and modifying views such that you use pre-built components, you automatically increase the quality and reliability of the UI because it's doing less work. So that's why less code volume while still solving for complex challenges. Like, for example, accessibility is always an afterthought. It's a very important problem, and one of our classmates from HBS has a startup dedicated to this, I believe, Test Party, Michael Bowell. Shout out to him. So that's a very hard problem that people have spent a lot of time, and it's always an afterthought. But this incorporates all of the goodness of accessibility, of responsive design, and all of that into your UI so that you can focus on the problem statement and the AI can focus on getting everything right according to your rules and guidelines.
So Arc is really the first component library that was designed specifically for agents to use it efficiently and effectively to match the design intent, the brand intent of the organization while allowing the AI to do the work.
Yes, so that's a very important point that you bring up. So it's not just about, we describe what it does at runtime, but when we wrote Arc, we created a storyboard and we created a custom MCP that is internal to retrieve the contents of the storyboard and the Figma. Right? And it's documented by AI for AI. It's optimized such that when an agent tries to figure out which component to use, it has access to the right amount of documentation that can help it figure out the closest compatible component if it cannot find a perfect match. Right? So that's a huge advantage because at runtime, it enables the AI to be efficient, but there's no component library as of today that helps you achieve that, and that was built specifically for this purpose.
And so we think about getting component libraries agent ready. We have Blitzy's Arc library that is end-to-end component ready, and then we have the ability for their enterprise to bring their component library and for us to turn that into its current state to agent ready, which just means we're really changing the interaction system. We're not changing any of the components themselves, so that when the Figma screen comes in, we can select and leverage all of the enterprise-specific components, put those into place against the brand guidelines, against all the specs, and if that enterprise doesn't have a component that they've designed in the screen, we can go leverage one of ours, like a date picker. It's not common that an enterprise would have their own date picker, so we could fill that gap, provide that pre-designed agent-ready component within the UI, and ultimately have a really rich UI experience that operates with the backend fluidly.
Exactly, and if you look at this is the hard problem, right? Like getting UI out of an agent or converting a Figma into code is not a hard problem. What's hard is how do you account for the design system, the component library, all of the atomic components, use the correct components in the correct places, have it scale across different screen sizes and different platforms like TV or mobile, and apply the correct theming. So the Arc supports theming out of the box. It supports multiple font choices out of the box, right? And then after you've done all that, integrate that with your backend while having context across your entire code base, right? So that is something unique that you cannot do with some of the other tools out there, which is why we took the time to perfect this and solved the correct sequence of problems to get here.
If you think about what the traditional website builders did with the front end, where they would sort of like predefine all of these components like Webflow or Wix, and that would work with all of the screen sizes, like this is that for agents, right? Which is like a CMS for agents that can dynamically build UI against your use cases. And I've not seen this anywhere.
Yep. We've been thinking about this for a very long time. We've been fortunate enough to see multiple people take shots at this problem.
Yeah.
But we've been confident in our approach.
Yeah.
And we're super excited that this is now coming to fruition and our users can experience this.
Yeah. In the coming
weeks.
Coming weeks. Yeah. It's super cool when you see it, though.
Yes.
It's super fun. All right. Any other sneak peeks into what's coming in the coming months to quarters?
I think we want to expand. We want to go deeper into getting developers to love Blitzy. So we're significantly speeding up indexing.
Yeah.
Where you click if you create a branch from a source branch, it will copy over the tech spec such that you don't have to keep waiting for syncing to happen. We're opening up the black box and we're showing our users what Blitzy is doing behind the scenes.
Yep.
So if a job is taking a while, at least you have an idea of why that is the case. And we're opening up Pandora's box for integrations for enterprise. So if you, as a viewer, are from an enterprise and you would like a particular integration, could be GitHub, could be GitLab. We already support GitHub. We recently added Azure DevOps for an enterprise. We could do GitLab or Bitbucket, and we do that for enterprise plans. So get in touch with us. We're not limited by what integrations we can do. Yeah.
Well, awesome job on compiler. I know people are very excited about it. The customer reactions, I'm talking to these customers every day. They're like, wow, like this is like just a different category. This is a different thing than the auto-suggest or even like the other long-running coding tools that aren't compiling every single time. And so resolving those issues for the developer that wants to move faster with AI, like this is the next step. And we're just getting started.
And drawing from that, there's one very important thing we're doing, which is as we go deeper into the enterprise and have these interactions with enterprise customers, we're realizing that we want to align with their SDLC model.
Yep.
Right. And we've completely changed the internal process inside Blitzy to ground it in using Blitzy to build Blitzy.
Yeah.
And we're being advocates for the enterprise to help them do exactly the same.
Yep.
Right. So what that means is in the Jira, when you start your development sprint, you have a series of tickets, right? And the challenge for developers is traditional software development has always started from a ticket, and developers have taken a problem statement and transformed that into code. What we're telling enterprises is now that is an obsolete model. You're going to start from a ticket and you're going to start from a Blitzy PR. And the developers are going to take code to completion. And the quantum of work that developers have to do to take code to completion is going to keep trending downwards, unless it's a really complicated problem that the AI could not solve to 100%, in which case we've documented what we could not do and made it easier for the developers to take it to 100%, such that it is far, far better than starting from scratch or doing it yourself with a copilot.
Yeah.
But the key point here is you could take a batch set of tickets and feed it to Blitzy, and Blitzy could create tech specs, and these are target tech specs, which is, it's more of an agent plan than the tech spec.
Yeah.
And you could go straight to approving the agent plan or reviewing it and go into code generation rather than having to create multiple projects corresponding to each ticket.
Yeah, and really we're seeing a slight shift in the operating model to get this. So the best practices that we've seen across the enterprises are whoever's leading that agile sprint, the sprint leader, the scrum leader, the EM, the architect, whatever this person is in your enterprise, a day before that sprint starts, they're bringing those tickets, they're running them through Blitzy, and then instead of just handing over words, You're handing over code and a project guide to that developer, which is a much, much, much faster starting point for them to take that to completion. And they're doing this sprint over sprint over sprint over sprint. And they're able to get dramatically more work done because it's inherently faster, right?
Yes.
We live, the average enterprise today not using Blitzy is in the AI assisted SDLC, where the SDLC is this long multi-step process, and the only time they're effectively inserting AI is right at the IDE, right at the last step where they're going to help produce some code. This is pulling AI across the SDLC, right? Leveraging a broader system that understands the entirety of the context, is able to drive changes with that context, use lots of inference time compute, lots of algorithms, lots of validation to drive really, really strong code, and then go ahead and use your AI assistant within the IDE to finish towards 100%.
Right.
But we want to leverage generative AI across the entire SDLC, which is exactly what Blitzy is bringing to the enterprise.
Yes.
Cool. Back to work.
Yep.